triangles.
Thank you.
Okay, we ready? We all found it? Okay, great. So, number 13 says, given rectangle RECT, find X first. So what we need to remember is that in a rectangle, all angles are right angles. So when they ask us to find X, I'm going to use this triangle right here to help me find X. So I'm going to redraw that triangle. And we have ECT. TC is 10, ET is 26, and EC is X, which is what I want to find. Would it be fun to do the Pythagorean theorem on 10 and 26? That's not fun. That's very big numbers. So I don't want to do the Pythagorean theorem on very big numbers if I don't have to. So I'm going to look at 10 and 26 and ask myself, is there a number that divides evenly into 10 and 26? Yes, what number? 2. So I'm going to go ahead and I'm going to make a new smaller triangle by dividing by 2. When I divide by 2, I get a 5 and a 13. Triple. 5 what? 13. 12. Is 12 my answer for X? No, I divided by 2. Now to go back to find X, what do I have to do? Multiply by 2. So we get X is equal to 24. So I'm not going to take points off, but what's going to end up happening is you're going to end up with a really big radical, and then most likely you're going to mess up somewhere trying to simplify that radical. So you'll get partial credit. If you get it completely right, then you're going to get the points. But like I said, most likely you will mess up simplifying that radical. So now we want to find the perimeter. Now that we know that X is, what did I say it was? 24. Now that we know X is 24, we have to remember more things about a rectangle. What do you know about the sides across from each other in a rectangle? They're congruent. So if TC is 10, RE is 10. If EC is 24, RT is 24. So our perimeter is going to be 10 plus 10 plus 24 plus 24. 10 plus 10 is 20. 24 plus 24 is 48. So our perimeter is 68. Did we learn about 30, 60, 90 triangles yet? No, right? We didn't learn about those special triangles. Hmm. All right, we're going to skip 14. That goes more with the 30, 60, 90 triangle. Let's do this. Let's go to 15. So here we have a trapezoid. You want to make sure that you're reading all of the given information. They're telling us that CD is 36. I want you to mark it exactly how I'm marking it. So you're going to draw a bracket from C to D or D to C and label it 36 like that to show that whole length is 36. Okay, now we've talked about this. We've talked about this before. When you have a trapezoid and we draw down these altitudes, what shape is in the middle? What shape is it? A rectangle. When you have a trapezoid and you draw down those altitudes, you end up with a rectangle in the middle. And we need to remember that in a rectangle, the sides across from each other are congruent. So if AB is 15, FE is 15. If AF is H, what does that mean for BE? It also has to be 8. So when it says find H, we found that H is 8. Now, it did not tell us that this trapezoid was isosceles. Because it didn't tell us that the trapezoid is isosceles, I can't assume that these triangles are congruent. I could only know these triangles are congruent if they tell me the trapezoid's isosceles. But because they didn't say it, I can't say that the triangles are equal to each other or congruent to each other. So now I have to work with each triangle separately. I'm going to work with this triangle first. It ends up being a triple. 8 something 17. What's that missing side? 15. Do you guys see why it is so important to know the triples? Okay, now even though it doesn't look this way, I just showed that F to E is 15 and E to C is 15. They don't look like they're equal lengths. But remember, nothing's drawn to scale, so that's okay. Now, if the total length from D to C is 36, and this is 15 and this is 15, isn't that 30 units altogether? 15 plus 15 is 30. What does that mean DF has to be how long? 6. Perfect. So DF is 6. So now we're going to use this next triangle. Once again, it's another triple. I love using triples. So now this is a 6, 8, 1, 10. Now that we found x, we are now able to find the perimeter. So, x is 10. So the perimeter is going to be 10 plus 15 plus 17 plus 36. I guess I'll add this. 10 plus 15 is 25. 17 plus 36, not as nice to add, huh? 17 plus 36, carry the 1, and we're going to get 53. And now we're going to have 53 plus 25 is equal to 78. Yeah. So now notice in 15, I did not say it was isosceles because it was not isosceles in 15. Those two side triangles were not congruent. But in number 16, I am saying it's isosceles. Because it is isosceles this time, guess what? Those two triangles are congruent, which means their sides that correspond are the same length, which is nice for us, makes our lives easier. Now they're telling us this time that CD is 20. So from C to D is 20 units long. No matter what, do we always get a rectangle in the middle? Yeah, no matter what, we get a rectangle in the middle. So FE is 10, which is M, so that's 10. And now this is where the rules come in to help us. Because these two triangles are equal, I have 20 total from D to C, but I have 10 in the middle. Doesn't that leave 10 units left over? Right? 20 minus 10 is 10. And because these triangles are equal, that 10 units is going to be split between each base. So what's 10 divided by 2? 5. So this base is 5 and this base is 5. And that's only true because that trapezoid is isosceles. We have a triple. Look at triangle ADF. 5, 12, what? 13. Good job. So if AD is 13, which other side has to be 13? BC, because it's isosceles. So X is 13. Now the perimeter. So the perimeter is going to be 13 plus 10 plus 13 plus 20. I'll add the 13s together first. 13 plus 13 is 26. 10 plus 20 is 30. So our perimeter is 56. The end of it? Okay, so that is the end of day 2. I'm now going to let you, or I'm going to say you have to, work on the homework in class. I'm going to be coming around to check and help you. You will get credit for this, so make sure you do it and submit it.